Hi everyone, welcome back to another Calculus 12 video. We're going to be looking at 7.1 today, which is limits of trigonometric functions. I'm going to build in a little bit of review because I realize you may not remember everything. And we'll do a quick lesson with a few examples that will help clarify things for you. So just starting off by looking at this graph on the left, first I'll say we could do this without the graphs. I just thought it would be nice for you to be able to put a picture with what the actual limits equal to so that you can make sense of it. So if we take a look at this one that's on the left here, notice the stuff in pink, the limit as theta approaches 0 from the left. Notice that the y value is approaching 0 on our graph, on our wave. And the same thing is also true with the blue part. If the limit as theta approaches 0 from the positive side, notice that the graph is again reaching 0 for the y value as the x value is approaching 0 from the positive side. So you can see they're both equal to 0. So that's how we come up with this first rule in the first box. The limit overall of theta approaching 0, or it could say x approaching 0, for sine of theta is equal to 0. Okay, let's look at the one on the right with the cosine graph. The limit as theta approaches 0 from the left. So this pink stuff, that's what the little minus sign up there indicates. We're approaching from the negative y values, is that the y value is approaching 1 at that point. And if in blue, the limit as theta approaches 0 from the positive side is equal to 1 as well. And so overall, the limit as theta approaches 0 for cosine theta equals 1. So you get to see again where that comes from. And then moving on to the third rule, which is one that you'll just have to sort of know or memorize, is the limit as x approaches 0 of sine x over x is equal to 1. So we're going to use and take these three rules and simplify some examples that are a bit more complex. So we'll start off with this one. It kind of, I think, will feel a little bit like it's a puzzle. We're just basically trying to use our simplification skills to start to break things down so that we can work our way through this. So one way we can do that is we can write sine x times sine x to represent the top part here. So recognizing that it's nothing different, it's the same thing. And then I could also separate the bottom to say x at the bottom, separate that from the cos x. So I could say here, this is times cos x. I mean, that's a weird looking fraction. I probably should draw them separately like this. The reason we've done that is, do you see that right here? Sine x over x, we know is equal to 1. So this is just the number 1. And then if we take a look at these separate parts, the limit as x approaches 0 of sine x from over here would be equal to 0 for the top part there. And the limit as x approaches 0 for cos x, which would be this part here, we know is equal to 1. So overall, this thing ends up giving us an answer of just 0, because 0 multiplied or divided by anything is 0. So there's the first example. This kind of resembles stuff that we've done before in pre-calc 12. The difference is now we have the limit. And so I would say, as always, if you are working on this at home, that you should pause the video at this point and maybe give it a try on your own. Although I just said that, but now that I look at it, you probably need me to go through this first one with you. This, if you look at it, it kind of looks like the third rule. So notice the third rule. It says the limit as x approaches 0 of sine x over x, meaning the thing that you have at the top is the same as the thing at the bottom. So if you look at this, it almost looks the same, except for the fact that we have a 3 and a 5 as a coefficient. So one way that we could deal with this is I could actually multiply both top and bottom by 3 over 5. That's a strategy that we can use to start to simplify things here. The reason why I did this is at the bottom, do you see that the 5 and the 5 would cancel? So if I were to rewrite this, I'm going to factor out the 3 over 5 to the front, like this one here. I'm going to factor out and like move it to the front. And then I would be left with the limit as x approaches 0 of sine 3x at the top. And then now at the bottom, I also have a 3x. So I know that this whole thing is just equal to 1. So my answer after all that is just 3 over 5. So notice that strategy, it'll come up again, but it just makes it a little bit easier for you to be able to work with, and to, when it's tangled up in here, that allows us to untangle it and to get just a number without the limit there. Okay, moving on to another one. This is why I say this every single time. It probably in a lot of ways feels like review because we deal with stuff like this often. We often look to the conjugate when we see something like this. So if you see cos x minus 1, we can multiply by cos x plus 1 over cos x plus 1. This is way too thick. Let's fix that. Okay, so the reason why I thought to do that, and again, I'm sort of building in review and doing this, but the reason why I thought to do that is because we know from past experience that sine squared, you know what, let me do a different color so it's not like messing things up. And let me shrink that down a bit. But remember that sine squared x plus cos squared x is equal to 1. Okay, sine squared x plus cos squared x is equal to 1. So when you do that, so the limit as x approaches 0 of, when you do this at the top, do you see that when we multiply it out, we're actually going to end up getting cos squared x minus 1 when we, FOIL it out and distribute everything. And cos squared x minus 1 is the same thing as if I rearrange this. So let's say like cos squared x minus 1, that would be negative sine squared x. I am butchering this thing. I hope you can still make sense of this or see it, but we're just rearranging this Pythagorean identity from pre-calc 12 that you probably remember, and if not, don't worry, we're going to repeat this over and over again, so it's going to come back pretty quickly. Okay, so now that we know that, at the bottom, sorry, I didn't finish this. We just have like x times cos x plus 1, like that. Okay, so when we look at this whole thing is what I'm saying, like cos squared x minus 1 is equal to negative sine squared x. So I can just substitute that into here. In fact, I'm going to do that. I'm going to cheat because I have technology. I'm just going to wipe this all out and say that's the same thing as sine squared x. So I hope everybody sees and understands where I got that from, because I just took it and substituted it in for this part, which was in the numerator. Sorry, this should be negative sine squared x in order to make sense of this. Okay, so now that we see that, I want to start to clean things up a little bit. So I'm going to move the negative out front. So I'm going to say negative and then the limit as x approaches 0. And at the top, I'm going to have sine squared x, and then at the bottom we had oh, actually, let's do this. Do you see that I could change that? Instead of sine squared x, I'm going to separate them just like before. I can multiply them, so sine squared x is just sine x times sine x, and then I can separate it by putting the x down here, down there, and I can take this cos x plus 1, and I can do this over cos x plus 1, and I can do this. So I hope that you're seeing the pattern, and I feel like my color coding's a bit off, but I hope that you're able to keep track of what's coming from where, and this is making sense. And so again, if we work our way through this, I'll try to keep things lined up so you can make sense of what's happening. So I do have the negative sign there. And then if you pay attention to this part, the limit as x approaches 0 of sine x over x, we know that that's 1. So I can get rid of that and just substitute in a 1. So that helps to take care of that part. And then when we move to the other part, well, the limit as x approaches 0 of sine x, so of this part, we know is equal to 0. And we know that of cos x is equal to 1, and then we already had the plus 1 down there. Although the truth is, it doesn't matter what on earth we have, because as long as there's a 0 in there, we know the whole thing is going to be equal to 0. So that's what we get as our answer, right there. Okay, So again, hope you found that helpful. Let's do another quick example and then we'll call it a day. So the limit as x approaches 0 of tan x over x. Okay, this is again built-in review. I just don't want to write limit over and over again, so I'm going to put equals and just keep working horizontally, but know that each time the limit should be there. But we can rewrite tan x. Remember, this is the same thing as sine x over cos x, and then the whole thing over x. Okay, which I could also say is like the same thing as x over 1. And the reason I'm doing that is just to show it's one fraction divided by another, because when we do that, to solve it, we would flip it and multiply by the reciprocal. So I'd get sine x over cos x equals, and then I would get 1, or not equals, sorry, times 1 over x, like this. Hope you're still with me. All I did is, when you're dividing a big fraction like that by another big fraction, remember we can flip it and multiply by the reciprocal, which is what we have done right here. I am going to move it down here. Limit as x approaches 0. Clearing our way through this, so to draw your eye and attention back to the part that we are at this part here. We've just simplified things to make it look like that. Notice that I can take the sine x over x, and I can clump them together because I know that that will allow me to simplify things. Okay, then the other part, if I want to deal with the other part, or what that leaves me with, is this 1 at the top over cos x. I'm going to just write that here, 1 over cos x. And so when we work our way through both of these, well, we know that the limit as x approaches 0 of sine x over x is equal to the number 1. So I've dealt with that part. I've done the limit of it and everything, and I get the number 1. And then for the other part, times, at the top we still have that 1, but at the bottom, the limit as x approaches 0 for cos of x, remember that that would be cosine of 0 that would be equal to 1, right? So the limit as x approaches 0 of cos x is 1. So overall, we get the answer of 1. Okay, I hope you found that useful. I'm giving you some work here. Those of you who are working at home remotely, I would say reduce the amount here. I said odd numbers, like 7, 9, etc., but you could also even do half of those, like odd letters out of those if you like. And, you know, the usual. You decide if you are struggling, you need more practice, do them all. If you have gotten the swing of things, try the hard ones at the end and skip the earlier ones if you feel confident that you've gotten it.